Hello viewers, I am Kausalya. Today we are going to solve problem 4 in exercise 13.2. The problem is a pen stand made of wood is in the shape of a cuboid with 4 conical depressions to hold pens. So now we are going to discuss about a pen stand, right? So what is its shape? It is in the shape of a cuboid, right, with 4 conical depressions. So here we are going to discuss about a cuboid and a cone, right? And now we are going to, you see here the details of dimensions are given. So the dimensions of the cuboid are 15 centimeter by 10 centimeter by 3.5, right? The radius of each of the depression is 0.5 and the depth is 1.4 because it is in the form of a cone, right? So here the radius is given and the depth is given. So find the volume of wood in the entire stand, right? So here you see this is the diagram which is given. So this is a cuboid, right? This is your pen stand which is in the form of a cuboid, and here the dimensions are given, right? 15, 10 and 3.5. So here this is your 15 and this is your 10 and this height is your 3.5, right? And next the thing is the radius of each of the depression, that is for cone the radius is given. Okay, this is in the form of a cone inside, right? This just like this. On the top it is in the form of a circle and inside it is a cone. So here the radius is 0.5 and the depth is 1.4, right? So here the thing is about a cone here, right? This is a cone, that is this depth part is in the form of a cone and the radius is 0.5 and the depth is 1.4. Now we have to find the volume of wood, right? So how to find the volume of wood? Initially we have to find the volume of the conical depression, right? Then we have to subtract that volume from the volume of the cuboid so that we can find the volume of the wood, right? So first we are calculating the volume of the cuboid. So here it is L into B into H. So 15 into 10 into 3.5. So 10 into 3.5 becomes 35 and 15 into 35 gives you 525 centimeter cube because it is volume. Next we are going to find the volume of the conical depression, which is nothing but volume of the cone. So what is the formula for volume of the cone? It is 1 by 3 pi r square h. The radius and height are given in the problem directly. So just substitute the values. Radius is 0.5 and the h is 1.4. Right. So here, since it is a 0.5 square, I am writing it as 0.5 into 0.5. And here we can cancel this, that is pi is nothing but 22 by 7. So the 7 and 1.4 they cancel by 0.2 times. Right. And once you simplify, we are getting the answer as 1.1 by 3. Again, since it is a volume, it is centimeter cube. Right. So this is a volume of a conical depression. So how many conical depressions do we have? We will look back at the problem. So how many conical depressions? We have 4 conical depressions. You see 1, 2, 3, 4. Therefore, volume of 4 conical depressions will be, you see this is a volume of single conical depression. Since we have 4, we have to multiply this term by 4. So 4 into 1.1 by 3, which is nothing but 4.4 by 3. Again, when you simplify, we are getting the answer as 1.4666. It goes on. So I am writing it as 1.47 centimeter cube. Right. So now we are going to find the volume of the wood. So how to find the volume of the wood? Which is nothing but volume of cuboid minus volume of 4 conical depressions. So volume of cuboid, it is 525 and volume of this 4 conical depressions are 1.47. So here when you simplify, 525 minus 1.47 gives the answer as 523.53 centimeter cube. So finally this is the volume of the wood, right? The next is problem number 5. So here the problem is a vessel is in the form of an inverted cone. So here we have a vessel in the form of an inverted cone. Its height is 8 cm and the radius of its top, which is open, is 5 cm. It is filled with water up to the brim. When lead shots, each of which is a shape of spear of radius 0.5 cm, are dropped into the vessel, 1/4 of the water flows out. Find the number of lead shots dropped in the vessel. So, here you see, we are discussing about a vessel which is in the form of a cone, okay, which is inverted, right, which is kept reverse. So, normally a cone will be like this, right. So, but here it is inverted, it is like this. And height and radius is given, right, and it is filled with water. Fine. Now we are dropping lead shots, okay, we are dropping spears, right. We are dropping spears whose radius is 0.5 centimeter. And you see, when lead shots, which is shape of radius 0.5, okay, when lead shots are dropped into the vessel, 1/4 of the water flows out, right. So we are dropping some lead shots into the vessel, and water, how much of water flows out? 1/4 of the water flows out. So we have to find how many number of lead shots are dropped into the vessel, right. Do you understand the concept here? Here we are again discussing about two shapes. One is cone and another one is spear, right. So initially the cone is filled with water totally. It is completely filled with water. Now by dropping some spears into it, 1/4 of the water flows out of the cone. And now we have to find how many lead shots are dropped into it. Right. And again they are clearly given, you see. The spear, that is lead shots are in the shape of a spear whose radius is 0.5. Right. So first we start our solution by finding the volume of water in the cone. You see, this is the inverted cone. Its radius and height are given. So to find the volume of water in the cone, we have to calculate the volume of the cone, okay, because depending upon the capacity we will be having water. So it is given by the formula 1/3 pi r square h. Now here the value of r is 5 and the value of h is 8. So just substitute the values, and finally here we are having an answer of 200 pi by 3 centimeter cube. Right, so this is the volume of the cone or volume of the water. Now we are going to calculate the volume of the spear because lead shots are in the shape of the spear and the radius is given as 0.5 centimeter. Right. So let us denote the radius of this spear as capital R. So here the volume of the spear is given by 4/3 pi r cube. Right. So 4/3 pi, the value of r is 0.5. So again, in order to simplify, we can write 0.5 as 1/2. Right. So just write it as 1/2, and 2 cube is nothing but 8. So 1/2 cube is 1/8 here. So again, when you simplify, we are getting the answer as pi by 6 centimeter cube. So this is the volume of the spear. Right. So what is the volume of water that flows out? Volume of water that flows out is equal to 1/4 into volume of water in the cone. Right. Because what they are telling, we are dropping some spears into it, okay, some lead shots into the water, so that 1/4 of the volume of the water flows out. So what is the water that flows out? 1/4 of its volume. So 1/4 into, what is the volume here? We have calculated the volume of cone as 200 pi by 3. So just substitute it over here. So what is the amount of water that flows out? It is 50 pi by 3 centimeter cube. Right. Okay, now listen carefully. Let x be the number of lead shots dropped in the cone. Right. We don't know how many lead shots are dropped into it. We are keeping that count as x. Right. So what is the thing which is given in the problem? We are dropping some lead shots into it, right? Let it be x. So therefore, x into volume of one lead shot makes 1 by 4th of the water flows out of the cone. Can you get? We know, just listen. We are dropping some lead shots, okay, some spears into the water. Due to that, 1 by 4th of the water flows out of it, right? So, let x be the, for example, just assume, okay, let x be the number of lead shots which we are dropping into it. So, what is the volume of that single lead shot? It is nothing but pi by 6, right? So, for example, I am telling, suppose we are dropping some 10 lead shots, right? So, volume of one lead shot is pi by 6. Now, what about the volume of 10 lead shots? It is nothing but 10 into pi by 6. Understand? The same thing, but now we don't know this value. So, we are keeping this value as x. So, x into pi by 6, when you drop this much amount of lead shots into the water, what happens? 1 by 4th of the volume of the water flows out. So, what is the value of 1 by 4th of the volume of the water? You see, we have just now calculated. So, this is the volume of the water that flows out, right? So, which is equal to 50 into pi by 3. That is, we are dropping some lead shots, right? And volume of one lead shot is pi by 6. We don't know how much lead shots we are dropping. So, here we are keeping it as x. So, when you drop these lead shots, what happens? 1 by 4th of the amount of the water flows out. So, this is the volume of the water that flows out, right? So, we can easily now calculate the value of x. So, x is equal to 50 pi by 3. When you move this, here it becomes pi by 6. Okay, this occupies the denominator part. And again, when you move this pi by 6 to the numerator, it becomes 6 by pi. And when you simplify, here we are getting the answer as 100. So, therefore, number of lead shots dropped into the vessel are 100 in number. Right. So, that's all. If you have any doubt, let me know in the comment section. Thank you.